Hi guys, this is our first session of UVM. So actually UVM is nothing but a universal verification methodology. So all things of SystemVerilog are valid inside that. Only there is a concept of factory, right? So we need to register our class inside that factory, and we can call very much inbuilt method from that factory, right? So let's see this is their factory structure. Actually as you can see, there are two main things in in UVM. One thing is object, one thing is component. So this is our base class. This is something called UVM root, and UVM object is extracted from UVM void or extended from UVM void. Similarly, UVM report object is extended from UVM object, and this UVM component extended from UVM report object. So UVM driver, UVM monitor, UVM sequencer, UVM agent, UVM test, UVM environment, UVM random stimulus or UVM scoreboard and subscriber, they all are component, right? And extended from UVM component. And in our Testbench structure, we actually extend our driver class from like UVM driver, monitor class from UVM monitor, sequencer class from UVM sequencer. Same the concept of polymorphism, right? And this is the object. So UVM sequence, sequence item, and sequence base. These are our object classes, right? So these three are object, and rest of all are component. So let's see the Testbench structure of UVM. So similar to SystemVerilog, there is topmost module is top module, as you can see over here. This is our top module, consist, test, and interface with DUT, right? Inside top there is something called test. Test consists environment and agent, right? Inside environment there is something called scoreboard and agent, and inside agent there is sequencer, driver, and monitor. As you can see, there is a new concept of TLM, means transaction level modeling in UVM. So as you can see, this is the symbol for that, and this is also a part of TLM, right? And this is this notification used for interface, right? So sequencer is similar to SystemVerilog generator, used to send the sequences towards driver. Function of driver is to convert this sequence to signal level modeling and send to DUT, and back DUT send these signals to monitor as output, and monitor send this to scoreboard. So the major difference between SystemVerilog and Testbench structure, as you can see over here, actually inside in our SystemVerilog structure, driver is also connected to our scoreboard. We or sometimes we also called it as golden model, right? So that whatever we are whatever the input sending to the driver to the our DUT, the same input should send to the predictor, and now my predictor has the input, and when the output comes from DUT and it's captured by monitor, monitor sent to our golden model, and this have the now this have the output of our DUT for the same input as it have, but their own logic generates a separate output as per the input provided by the driver, and it will compare the both output whether they are same or different. So this is that was the way of SystemVerilog, how to verify whether the output is correct or not. But in UVM there is no need to connect driver to a scoreboard, because the driver sending the stimulus towards interface, and DUT generates the output. Same stimulus can be captured by, means the same input whatever the driver sending towards the DUT may be captured by our monitor, and also it will takes the output of our DUT and send to the scoreboard. Now scoreboard has input and output. Based on the input provided feeded by the monitor, it will generate their separate output as per the golden model logic, and compare the both output whether they was correct or not, right? So let's see. So actually UVM has two main elements. One is called component and another one called object, right? So what is the difference between them? Actually they get created at the beginning of the simulation and will exist for complete simulation time, right? Examples are monitor, driver, test, like that, and objects that gets created during the simulation and get consumes and allocated. The examples are like packets and sequence, right? So let's understand this block diagram. What is the functionality of each block, right? So first of all we need to understand that top module. Okay, let's understand, first of all let's understand the hierarchy. Right, so first of all top, after that UVM root, after that test, after that environment, after that agent, after that inside agent actually driver, sequencer, monitor, and similarly here scoreboard, right? So this is the hierarchy. This is our topmost module is top module, right? So this is the hierarchy level. Now we will understand the functionality of each block, like what is top, what is UVM root, what is test, environment, agent, driver, like that, right? So first of all we need to discuss about top module, right? So what is top module? Static container, responsible for reset and clock generation, imports UVM package, factory registration of interface, and calling the test. So these are the functionality of the top module. There is no need to bother about that in depth too much. When we will discuss the coding part, we will discuss each and everything in depth with practical example of that coding, right? After that, there is something called UVM test. Actually, there is something called UVM root. So actually, UVM root nothing but we are talking about the factory, means the root of this is the root of complete structure. When the our test bench is start, and inside the top module we already import the UVM package, right? So this is the same thing, the UVM root, where the structure will start. So next thing is test. So test class is extended from UVM test, and this is nothing but a pattern to target checks and verify specific features of an design. Right. After that, environment, extended from UVM environment, contains, you may have multiple reusable environments, and defines their defaults configuration as required by the application. After that, driver, extended from UVM driver, used to drive the signal on interface towards design, right? Responsible to convert TLM level transaction to signal level transactions, right? After that, something called sequencer. Extended from UVM sequencer. And generates data transactions as class object and send to driver for execution, right? After that, there is something called sequence. Extended from UVM sequence item and made from several data item which can be put together in different ways to make scenarios, right? They are executed by the sequencer. Actually, they are extended from UVM sequence, not sequence item, right? The main stimulus written in the body, while pre-body and post-body useful like callbacks. After that, the next block is monitor. extended from UVM monitor responsible to capturing the signal level activity from the design interface and convert back into TLM level, right? TLM analysis port to broadcast captured data to others. Right. Next thing is our UVM agent. Extends from UVM agent. Contains like a sequencer, driver, monitor, right? There are two types of agent. Active and passive. So what is the mean of the active? Means like instance all three component sequencer, driver, monitor. Enables data to be driven towards DOT, right, by a driver. And what is passive agent? This is only, it has only instance of monitor. Used used for check-in and coverage only. Useful when no data item to be driven to dirt, right? After that, scoreboard. Extends from UVM scoreboard verifies the functionality of a design and it is usually receive TLM object captured from the interface of a dirt via TLM analysis board, right? So guys, this is the basic idea of UVM. So what is the, as we can see over here, what is the functionality of each block? So this is our first session, and in coming session we will discuss each and every block with their coding part, right? So guys, if you have any doubt, then please make a comment. Thank you.